So now in this one we are going to dive more in the concept of the derivatives, and we are going to explore how derivatives work when the function is not linear. So we explored the linear function in the previous video, and now we are going to make sense of the function which is not linear, which will be looking like this. So when we looked in the previous function, the rate of the slope, rate of like this slope or derivative, it used to be similar. Like any place you're going to take the slope, then it is going to be 3. But in this thing it will going to be some different case. So let's dive in. So let's get a function for our equation. So let's get f of a, function of a is equal to a square. So that's a equation for this line or this thing for us. So this is a square. Let's this is not a square. Let's assume a is 2, and if a is 2 here, then in this axis our value is going to be 4. So that's the a square, that's what I was trying to say. And if we nudge a by infinitesimally small amount, like 2.001, then this value is going to turn out something like if a is going to be 2.001, I'm trying to write the mathematical equation so the further understanding will be easier. So f of a is going to be somewhat equal to 4.00401. So for now we are going to assume that that thing is 4.004. So that's what we write in the mathematical terms as d by dA of function of a equals to 4 when a is 2, for the value of a is true. That's how we write the whole thing. I hope the concept is clear until now. Now if a is 5, then function f of a is going to be 25, just as you guys expected. If a is going to be 5.001, then function f of a is going to be 25.010. So for this case, d by dA of f of a is going to be 10, because this is the difference. So when a is 5, when this thing is 5. Now what if you go to any calculus textbook, what you will be finding there is d by dA when f of a is going to be equal to d by dA of a squared, that will be equal to 2a. So this is what you are going to find in the textbook. And if you consider this thing as a 0.001, then you will expect f of a to go up by 2a. That's what this thing means. That's all it is. So Let's explore this concept with example. So we're going to explore first example. So let's assume f of a is equal to a squared. Now d by dA f of a is going to be 2a, just by the definition from the textbook. And now if a equals to 2, then f of a is going to be 4. If a is equal to 2.001, then f of a is going to be like slightly equal to 4.004. So that's the first example. I hope that is clear. Now let's hop on to the second example. When f of a is equal to a cube, then what we are going to do is d by dA function of a f of a equals to 3a squared. You can get these formulas, by the way, from any calculus mathematics textbook, and you can use them whenever we are going to program neural networks using Python. You can go and refer to those formulas, so you don't need to be able to have the understanding and all those formulas like by hearted. You don't need to remember all of these formulas. By any time you can go to Wikipedia, you can ask any AI tool if that is working properly with maths, then you can ask that as well, or you can just simply search on the Google, that will work as well. So that's about the formulas. I'm just trying to make concept clear, how to understand the whole thing. So in this situation, if a is equal to 2, then f of a is going to be 8. If a is going to be 2.0001, then f of a is going to be 8.012. So whatever the type of curve we are going to have, so we explore the kind of curve in this thing. So the a square means we are getting some fluctuations in the value, not like the linear values. So that is what meaning, like the meaning of that is what, whenever we are going to take the slope of the triangle of any line here, like any point here, those things will be little bit different, and that's what the slope will be, and that's what I'm trying to explain. So I hope the concept is getting clear. So let's explore the function, like third example now. Let's explore a function where we are encountering the logarithm. So f of a equals log of a. Let's write log of a, ln of a, d by dA f of a equals to 1 by a. So that's the formula we got from the math textbook, and for the sake of understanding, log function looks like this. So when a is going to be 2, then f of a is going to be almost equal to 0.69315, and when a is going to be 2.001, then in this situation f of a is going to be slightly equal to 0.69365. So you can see the difference. So the whole idea between the equation is the whole thing is going to change by half, and by half what I mean is 0.5. So this thing is increasing by 0.005, like 0.005. So I hope the concept is getting clear, and there are two things. So we are going to write that down. D of dA f of a is equal to 1 by a. That's what we were talking about. And 1 by a is going to look like d of dA f of a. The value is going to be 1 by 2. So that's what it is. So from all these things, what we are going to derive is, first thing is, derivative is the just slope of the line. That's the first thing. And second thing is, you can open any calculus textbook, or you can go to any resource on the internet, and you can get those formulas. You just need to get intuition behind the formulas and how to use those formulas from the things that I'm teaching you, and that's all you need for programming stuff. You don't need to be calculus genius for doing the programming. That's what I'm trying to say. So I hope it was clear, and see you guys in the next one.